Hello and welcome in this new video where we are going to add the atmosphere to our planet. This is where we stopped last time, basically having the surface of the planet with some clouds floating above it. Right now we need to add the most important element, which is the atmosphere. By far the atmosphere is the hardest part of this course because there are different ways to fake it, and probably will find a lot of tutorials on YouTube that will show you different methods on how you can create atmosphere. The hardest thing about atmospheres is how to get the extinction. Most of the tutorials on YouTube will basically either show you that it is basically just like a solid sphere around the planet, or try to fake it later on in the compositor. In my opinion, this is some sort of cheating. I know probably all the shading work we do is some sort of fakery at the end of the day, but I would love to get the atmosphere right inside of Blender and basically get it as physically accurate as possible, and I don't want to later bother on trying to get that look. And that's exactly what we will attempt to do in this video, to try and create a physically accurate atmosphere directly in Blender. No trickery, no compositing, no anything. Everything will be rendered using cycles. So let's jump to doing that. First things first, I have my land selected right here, and I'm going to do Shift D to duplicate it. And since basically the atmosphere will also be above the clouds, we need to make the sphere slightly bigger. So if you remember, the land have a scale of 1, the clouds 1001. So I want this land 001, which I'm going to rename to atmosphere, to be, let's say, 1.002. So it is slightly bigger than the land and the clouds. I'm going to delete the material, and I'm going to create a new material, and I'm going to call it atmosphere. And since atmosphere is not just a surface, it is a volume, we're going to delete this principal, the SDF, because the atmosphere tend to scatter the light in a certain way. And what is the thing that scatters light in Blender? It is a shader called volume scatter. This one right here. This is the main hero of this setup that we will build. So I'm going to take the volume and plug it to volume. And from here, I'm going to change the color to a bluish earthy color, something like so. Here's the exact hex code if you want to get the same exact value. And I'm going to bring the density to something, let's say like 50, or let's say to 150. And as you can see, something is definitely happening. We're starting to add some layer of volume scattering, let's say, to our planet. But there are two issues. First of all, you will notice that it is not that high resolution. There is some sort of like squares appearing right here. The main reason for this is that we need to bump our subdivision level. We don't have even a subdivision surface. So to fix that problem, go to add modifier, subdivision surface, and we'll be good to go. You can even crank this to 2 and we're good to go. We fixed that first problem. The other thing is this effect right now is really strong. And here's the most important thing that you need to understand. We want this volume scattering operation to be some sort of a gradient. What do I mean by that? Basically, if I just zoom in here, and I need to show all of my overlays so that you will be able to see what I mean. What I want is that the atmosphere will be here, for example, a value of 1, and it will gradually fade to 0. The hardest part to get inside of Blender is how to get this gradient. And basically the only way to do something like this is by using some math. And that's exactly what we will be doing. We will be using a little bit of math to get this exact look, so that the atmosphere will be here strong and it will gradually fade beautifully into 0. So let's learn how we can do that. So let me get back by hitting 0 to my camera view. And let's try working on that. First thing I'm going to do is basically to add a texture coordinate, and just to exactly see what it does. And I need the object, so Control Shift multiple times until I jump to object. And what this will do is basically to give me let's say a representation of the coordinate of every single point of that sphere. And that's what all of these colors basically represent. As you can see, for example, the more I go to the left, the redder it gets, because red is in this direction, and that's why this color gets red. So what I want you to understand is that this is a visual representation of the different coordinates of all the different points on the surface of the sphere. And from this, I'm going to try to build a mathematical operation that will allow me to get the look I want, that smooth fading. To this, I'm going to add another node, which is called a vector math. I know the moment we start mentioning math, a lot of people get scared, but this will be simple. I'm going to add a vector math, and in the operation, I want the length. Where is length? Yeah, It is this one right here. Control Shift and click on it to see exactly how it looks. Let's just hide the clouds for a second. The length operation will give you the distance of a certain point on the surface from the center. Let me say that again. The length operation will calculate the distance of a certain point from the center to that point. For example, just to see, these points that are on the surface of the sphere will be a value of 1 because they are basically the furthest from the center. And the values that are inside the sphere will be 0.005 or 0.003, etc. And since 0 represents black and 1 represents white, if you start to imagine this in 3D, by doing this operation and if I plug it into the volume, I will start to get some sort of a 3D gradient. What does that mean? I will start to get a gradient that is basically in the middle or in the center of the sphere. It will be black and it will gradually go to white. And that's exactly what I want. This is what length operation is doing. Let me get back to the normal view and let me disconnect the volume. And to this, I'm going to add a math node, which is a usual math node. As you can see, we transform this from a vector data, which have 3 values, to a scalar, which has only 1 value. I'm going to plug this here and I'm going to change it to subtract, and I'm going to subtract 1 from it. So by doing this, I inverted that operation. Why do I do that? Because what I want is that I want a gradient that goes from white to black. After this operation, I get a gradient that goes from black to white. What I want is the inverse of that. I want a gradient that in the center it is white and it will gradually fade into black. So this subtract is responsible for inverting that. So this is the first step. As you can see, everything is black right now, so we need to start bumping the intensity of this effect. To do this, here's what I will do. I'm going to plug this into the density, and let's plug this into the volume, and let's disconnect this, and nothing is happening for now. Here's what we will do. I'm going to add a multiply node, and the main reason I'm adding a math node, not multiply. A math, and we select multiply. The main reason I'm adding this is basically to be able to multiply the intensity of what is coming out of here. I need to boost that signal. So I'm going to multiply it by, let's say something like 20, not 200, 20. Or you know what? Okay, we multiplied it. Oh, something is happening. Something is wrong right now. Let's try 20. Okay, something weird is happening. We're not seeing the effect right here for whatever reason. And my hunch is telling me that I need to do some displacement to it. Okay, let's just bring this here for a second and let's do some problem solving. The main reason we're not seeing any sort of volume scattering or any sort of atmosphere here is that basically all the atmosphere is right now basically in the center. And when it gets to the surface of the Earth, it is almost a value of 0. So what I want to do is to make this atmosphere slightly bigger. Your first instinct will be to, hey, you can scale this, but this is not the right way to do this. I'm going to do this using displacement. And here's what I mean. So I'm going to go Shift A and look for displacement, which we used plenty of times during this course. And make sure you jump to your material properties and scroll down and change this from bump only to displacement and bump. I'm going to plug this into displacement. And for the mid-level, I'm going to turn it to 0. And let's bring this to something like 0.00 or let's say 0.2. And boom, something is happening right now. We're starting to see this atmosphere. And as I said, the main reason we had that problem is because all the gradient or all the atmosphere was stuck inside the sphere of the Earth. We want it to go outward. So right now we have something looking like this. If I just zoom in to the edge, as you can see, we're getting that same look that you see in most videos out there, which is this ugly harsh line in the atmosphere. So right now our job is to somehow build a system that will allow us to get that smooth fall off. I'm going to add another node right here and I'm going to change the operation to divide. And I'm going to divide it by the same value as here. So I'm going to go Shift A and let's look for value. And I'm going to plug this here and plug this here. So basically whatever value I will plug right here, it will go to the divide and the displacement at the same time instead of writing the same value here and here. I'm going to change this to 0.02 and you will get something looking like so. What we are trying to do right now is to build a system for the gradient fall off. Divide is the first operation. The second operation after that, I'm going to do a multiply, and I need to lower this value, let's say to something like 20 because it is too intense. And if I just zoom in to the edge to see exactly how it looks, it is still a harsh line as you can see. So to get the gradient fall off, I'm going to duplicate this math node another time, and in the operation I'm going to change it to power. And I lost everything, so make sure to change it from base to exponent. And as you can see right now, we're starting to get the gradient fall off right here. If I just zoom out, this is the result we got. If I hit 0 to jump to the camera view, this is what it looks right now. The effect is still way too subtle, so I need to boost the signal. So to do this, multiply this, or actually duplicate this multiply node, and let's bring this value to something like 250, or let's say 50, because this is too strong. And yeah, this is starting to look pretty sick. For whatever reason, we still can see that some sort of a grid on the surface of the atmosphere. So the best solution for that is to actually bring this to something like 0.3, and you will start getting rid of it. Let's try 0.04. This is better. Let's try 0.5. Yeah, this is way better. So right now we nailed the volume scattering part of our atmosphere. And now to the last part of the atmosphere, because we need a volume scatter, and at the same time the atmosphere does have a property of absorption to it. That's why I'm going to also add a volume absorption node. Let's put it here, and let's just organize this node tree slightly. And for this volume absorption, I'm going to take the same value out of the multiply node and plug it to density. And let's change this color to something like brownish, and I need to mix both of these, so let's go Shift A and let's look for add shader. Let's plug it here, take this and plug it to shader. So right now we have a really simple setup for how we can emulate the atmosphere or the light scattering in the atmosphere of the Earth using this really simple setup. Now I know this might sound like it is really complicated, but actually once you just do a little bit of research and try to visualize, let's say, all of these different operations, this is really basic. Either way, let's just fly around the Earth, and let's also make sure to activate our clouds. And yeah, this is starting to actually look like an actual planet. The last part that I'm going to do is to jump to my render settings, and under under volumes, as you can see, you have step rate render. Basically, this is responsible on how smooth your volumes will be. The lower the number, the better quality you will get. For the sake of this course, I'm going to actually lower it as much as possible to 0.01, I guess. And same thing for here, 0.01. And this will give you a way better look to your atmosphere. Yes, it will slow your renders drastically, but I think that the result that you will get out of this is really nice, honestly. As you can see, we're emulating, or we're simulating how light basically acts in the atmosphere and all of that in a really nice way. And that's why basically this is a key to get this shader working the way it is intended, is to lower these values. And this is the usual trade-off. If you want like really outstanding quality, you will push your computer to the maximum and you will have more or less slow renders. So yeah, this is our planet right now. If I hit 0 to jump to the camera view, this is what we got. You can play with all of these different values until you start getting a result you're happy with. But yeah, I'm going to leave you with this. Don't be worried to experiment. Make sure to save your file also. And I will see you in the next video where we will actually set up a couple of shots to render. And later on, we will move on how to composite this shot. So yeah, I will see you everyone in the next video.